Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn about sampling distributions of sample means. A sampling distribution of sample means are created by taking many samples of the same size from the population and calculating a sample mean from each sample. Using means in a sampling distribution, we use x bar for a sample mean, and we use mu, the Greek letter, for a population mean. If we want to find the mean of the sampling distribution, the mean of our sampling distribution is going to be equal to the mean of the population. For the standard deviation of the sampling distribution, it'll be equal to our population standard deviation divided by the square root of n. And remember, n is the size of your sample. All right, our first example. The mean SAT score for Sun Lake High School students is 1,060 with a standard deviation of 200 points. Suppose 200 randomly selected students will be chosen to participate in an SAT prep class. Find the mean and standard deviation of the sampling distribution. So the mean is equal to the population mean, which is 1,060. The standard deviation is equal to the population standard deviation, which is 200, divided by the sample size, the square root of the sample size, which is also 200. So that was a little confusing, but it works out to be 14.142. All right, so this would be an approximately normal distribution because my sample size is greater than 30. Remember, that's from the last video. With a mean of 1,060 points and a standard deviation of 14.142. All right, number 2, a population has a mean of 136 with a standard deviation of 32. Describe the shape, center, and spread of a sampling distribution X for a sample of size 40. All right, so my mean is 136 for the population. The standard deviation of the population is 32, and the sample size is 40. So my mean is going to be equal to my population mean, which is 136. My standard deviation is going to be equal to my standard deviation for the population divided by the square root of n, which is 40, which works out to be 5.06. And then I'm going to describe the shape, center, and spread. So for shape, it would be approximately normal because of the central limit theorem where n, which is 40, is greater than or equal to 30, which is true. My center is going to be using my mean. The sampling distribution has a mean of 136. My spread will be using the standard deviation. My sampling distribution has a standard deviation of 5.06. All right, so if I drew this out, it'd be approximately normal with the mean of 136 in the center, and then I'm adding 5.06 each time I go to the right, and I'm subtracting 5.06 each time I go to the left. All right, go Seahawks.